This is now our second video looking at graphing inequalities and solving them. I appreciate they can be done often a lot quicker algebraically, but the focus of these questions is for us to be able to draw and solve inequalities. So we've got now the modulus of 2x plus x is strictly greater than 3. What I'm going to do is draw two different graphs on this one, and I'm going to draw the graphs. Let's first rearrange this and make things slightly easier for ourselves. We're going to say now the modulus of 2x is going to be greater, and I'm going to subtract x from both sides, 3 minus x. I'm now going to draw two graphs. Y is equal to the modulus of 2x and y is equal to 3 minus x. The modulus of 2x is going to look something along the lines, and we'll sketch this up like so. It's going to have a gradient of 2, and before it would have come through this way. Because it's a modulus function, what we're going to have now is a reflection in the x-axis. That is the graph now of y is equal to the modulus of 2x. What I'm now going to do is draw the graph of 3 minus x. So what we're going to have with this one is something that's flatter, and it will look, give or take, like so, and it will of course keep going on. What we want to do then is establish now where all of this modulus of 2x is going to be greater than 3 minus x. We can see two clear points of intersection. We can see one point of intersection when our modulus is positive and one intersection where our modulus is negative. So I'm going to consider two different things. I'm going to consider first, we'll take the positive branch. That's where 2x is going to be equal to 3 minus x. So if I add x to both sides, 3x is equal to 3, and then x is going to be equal to 1. So that point right there, x is going to be equal to 1. Now, if I consider this branch, this is the negative of that modulus. So what we can say then is negative 2x is going to be equal to 3 minus x. So if I add 2x to both sides and subtract 3, we're going to get minus 3 is going to be equal to x. So this point right here is where x is going to be equal to minus 3. We now have to consider when this graph, the modulus of 2x, is greater than x minus 3. And we can see that's the case here, okay? And we can see that it's going to be the case here. So what we can say for our inequality is that minus 3 is going to be greater than x, or x is going to be greater than 1. And those are strict inequalities. So there we go, nice and straightforward. We've graphed two different lines and then solved as a result. As stated at the start, algebra is also a possibility, but we're expected to be able to graph them as well. Okay, let's look at this scenario. In our work with inequalities before, we stated that we couldn't multiply through if we didn't know whether the denominator was positive or not. This one has to be, because the modulus of x has to be positive, and then plus 1 has to be positive. So whatever this value is going to be positive. That could be 0 thinking about it. I can't see any problems why it can't be. So what we can do is the following. We can now rewrite this, multiplying both sides by the content of the denominator. What we can have is x plus 3 is less than 2 lots now of the modulus of x plus 1. So what I've now got then is x plus 3 is going to be greater than 2 lots of the modulus of x, and then what we're going to have now is plus 2. I'm going to subtract this plus 2 from both sides, and we're going to have x plus 1 is strictly less than 2 lots of the modulus of x. We've got now two graphs to draw. One of them is going to be y is equal to x plus 1, and the other one is going to be y is equal to 2 lots of the modulus of x. So what we're going to have then, we hopefully know from either our work in this unit or C3 that the modulus of x is going to look, give or take, like so. So what we're going to have is something looking like that. Therefore 2 lots is going to be a scale factor stretch of 2. So what we're going to end up with is it looking something like so. So we'll end up with that scenario. So that's now our graph now of y equals 2 lots of the modulus of x. This one's fairly straightforward. This is going to be now y is equal to x plus 1. So we're going to have this on now, and we'll put this like so, and that is going to be a flatter graph, and it will look something give or take, and of course this will extend on like so. We can see from our graph that we have 2 points of intersection. We have one here and we have one here. That means that our modulus, we've got one on the positive and one on the negative branch. Starting with the positive, what I'm going to say then, if this is the positive, we're going to have 2x is equal to x plus 1. So subtracting an x from both sides, we can see x is going to be equal to 1. And that's that point of intersection right there where x is equal to 1. If we consider the negative branch, we're going to have negative 2x is equal to x plus 1. So adding 2x to both sides and subtracting 1, minus 1 will be equal to 3x. And x will be equal to minus 1/3. And that's that point just there, where x is equal to minus 1/3. We now have to establish where the modulus function is going to be greater than the basic linear function. We can see that that's going to be the point here. So if I take that, and I'll just draw it a different colour just to give you an idea, it's above the line here, right the way to there, and then it's going to be above the line just here. Okay, this is when this line is above that one. It's above it here. It's not above it in this little part here. So our inequality will be as follows. We can say that x is going to be strictly less than minus 1/3, or x is going to be greater than 1. And that now satisfies the inequalities. So that's a graphical way of solving these. Again, plenty of different ways around it, and you know, the video isn't judging the best way to do it, but it gives you some particular skills to solve these problems. Just a bit of a side note, often it's important, and I suppose I've left it out on these, to just ensure that we have our points of intersection. So if we look at this line here, on your graph in an exam, you might want to put that point here is going to be negative 1, 0, and this point right here is going to be 0, 1. That's where the line is intersecting the axis. You might want to put that on, and then on this one, if we have this is the line 3 minus x. So we'd have this point of intersection just here, and appreciate it's not wildly accurate. That's going to be 3, 0, and then this one is going to be 0, 3. Just to give you a bit of a heads up, I've left them off, but you might want to do that in the exam to ensure that you get full marks.